All right, so for problem number 14 and 15 on the homework 7, you were asked to rewrite a sum of both sine and cosine with different coefficients where the angle x or bx is the same for both sine and cosine functions. Now, the use for this is so that we can solve any equation where we have a sine and a cosine, but nothing to factor out. So we practice here first by rewriting this in the form where you have a new amplitude and a shift in your angle. So to do this, we expand k sine x plus phi. To expand k sine of x plus phi, we use the sum difference identities where we use x for our alpha and phi for our beta. So with the sine expansion, it's sine alpha cosine phi plus sine phi cosine alpha. Cosine alpha in this case is x. So here's our alpha and here's our beta. And because we have a k on the outside, we need to multiply all of this by k, and we will distribute that through and get k cosine phi. So I'm rearranging this so I have coefficients, sine of x variable plus k sine phi coefficient cosine of x variable. All right, now if k sine x plus phi is supposed to equal 3.1 sine of x minus, or let's say instead minus, plus a minus 6.2 or plus a negative 6.2 cosine of x, both of these two equations have to equal. If you notice, they both have sine values and they both have cosine values, or they both have sine terms and they both have cosine terms, which means the coefficients in front of each one of these have to equal. So k cosine phi has to equal 3.1 and k sine phi has to equal a negative 6.2. We can solve both of these equations for our cosine phi and our sine phi. Which means our cosine phi is equal to 3.1 over k, and our sine phi is equal to a negative 6.2 over k. Because I multiplied both sides by 1 over k. At this point, we can draw a circle with radius k. So this is negative k, and this is positive k. And we'll take this right here is our y, this right here is our radius, 3.1 is our x value, and k is our radius value. So if we mark this as 3.1 and bring it down over here, this is our negative 6.2. And we'll take this radius out, and this is k. Now, this angle right here is our phi. We can express phi as either this negative angle or the positive angle. The only caveat is they said phi needs to be greater than negative pi and less than pi, which means if this is negative pi, we want an angle anywhere from here all the way over here to positive pi. And if we wrote this angle here, our phi angle, let's make it more visible. This is our phi. If we made phi the positive version of this, it would be more positive than pi. So as the negative angle, it actually works better. Now, if we blow this up a little bit and make it a bigger triangle, we see that this side is 3.1 and this side is a negative 6.2. And we measure this angle here as phi. Now, this is the side opposite phi, and this is the side adjacent to phi. So we're going to use the inverse tan function to come up with phi. And the great thing about the inverse tan function is that it already gives us values. So the tan of phi then will equal negative 6.2 over 3.1. The inverse tan already gives us values in between negative pi over 2 and positive pi over 2. And so this one right here, the inverse tan of negative 6.2 divided by 3.1 is in the fourth quadrant where we want our phi to be, and it is negative between negative pi and positive pi. And this is approximately equal, using 4 decimal places, a negative 1.1071. So we have our phi. Now to find our k value, we use the Pythagorean theorem. Here's 3.1, here is a magnitude of 6.2. So that means k squared is equal to 3.1 squared plus 6.2 squared. And that reduces down to k squared is equal to 48.05. Taking the square root of both sides, k is equal to the square root of 48.05, which is approximately equal to, using 4 decimal places, 6.9318. So now we have our phi and our k, and we can rewrite the equation from above. Let's go back there. We can rewrite this equation, this 3.1 sine x minus 6.1 cosine x, as 6.9318 sine of x plus a negative 1.10714. This is a good solution to plug into WAMAP, but a better solution, in case you had further material to deal with, is the square root of 48.05 times the sine of x plus the inverse tan of negative 6.2 over 3.1. This would be the answer that you should turn in to me on your write-ups for these solutions. This is an acceptable one to plug into WAMAP.